welcome back. Today we're going to talk about sum and difference identities, and these are the next couple of sections are little outcroppings of using these trig ratios. And so today we're going to talk specifically about sum and difference identities, but you're going to get to a point sometimes where it's like, okay, I use this identity and then I get into a mode where I'm using a lot of 5.1 and 5.2, proving those basic identities. So as we go through this, hopefully a lot of these steps look familiar. Some of the strategies I'm talking about look familiar. And we're just going to play on some of these new principles. So I'm kind of checking out my notes here to see where we're going, and let's do it. First of all, we need to talk about what's not true. This would be awesome. It's like a lot of things in life. It would be awesome if it was true. Like if I could just sit on the couch all day and then think about going and dunking a basketball and just go do it. That'd be great. I got to work out to do that. And in my case, it probably would never work out. But what I'm saying is there's some things that we really want to be true, but they're just not. And here's one that's a very common misconception that students do. When we're talking about sum and difference identities, we're talking about adding angles or adding and subtracting angles. Okay, and so here's what's not true. So like if I say I have a sine of x plus y, so x and y are two angles, it does not equal sine x plus sine y. Okay, so it's not like the distributive property where you can just break it up into two things. That's a hard one for students to get over. Honestly, it was hard for me to get over when I was doing this as a student, is it seems so logical, you just break it up. But here's what is true. The cosine of a sum or difference. If I have the cosine of two angles and they are added or subtracted, and that should be a v because they're different. We're talking about different angles. We'll talk about the double angle identities tomorrow maybe, or the next day, I can't remember. So two different angles, u plus v. Here's what it is equal to. It's equal to the cosine of u times the cosine of v. And then here's a crazy symbol, minus plus sine u sine v. Okay, so this means that it's opposite of the original. Okay, so for example, if I've got cosine of, let's say 20 plus 15, it's going to be equal to, so here's a plus, it's going to be equal to the cosine of 20, the cosine of 15, times the cosine of 15. And because this is plus, this would be minus the sine of 20 times the sine of 15. Okay, and so the way that they're grouped is important, but look, I started out with two angles and I'm going to end up with four trig functions. Sine of a sum or difference. So for this one, it's going to be the sine of, and this is going to look the same, u plus or minus v. And it's going to be equal to the sine of u times the cosine of v plus or minus. Now notice this one stays the same. So if I was adding them in the original problem, I'm going to add them in this part. Plus the cosine of u times the sine of v. Okay, so they're kind of mismatched up like that. All right, so let's do an example. Using the cosine of a difference identity. So we've got this, find the exact value of cosine of 15. Well, this is not on the unit circle. It's not on the unit circle, but two angles whose ratios we know are. Okay, so here's what I'm saying. We may not have the ability to talk about ratios we know. May not have the ability to talk about 15, but we can rewrite 15 as 45 minus 30. Well, watch what happens here. Now you're kind of wondering, like, why would I do this? Why don't I just put it in my calculator? This is going to give us an exact answer, right? I want the exact value. And so what I'm going to do is I'm going to write this as the cosine of 15 is actually equal to the cosine of 45 minus 30. Don't simplify it. Leave it like that. And here's why. Using the sum and difference identity, we're actually going to be able to find the exact value by splitting this into, and I can rewrite this as the cosine of 45 times the cosine of 30. Remember, cosine is the opposite one, plus sine of 45 times the sine of 30. Why is this an advantage? Well, not on the unit circle, all on the unit circle. All of these we know. Okay, and so what am I doing now? I'm just subbing it in. So this is root 2 over 2. The cosine of 30 is root 3 over 2. So this is root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1/2. And so I've got square root 6 over 4 plus square root 2 over 4 gives me root 6 plus root 2 over 4, and that's my exact answer. I rewrote the angle that I didn't know the exact value as a sum or a difference of angles that I did know. I could rewrite this in a bunch of ways. I could use 60 and 45. I could have used, 135 and 120. Pick easy ones. Pick, first quadrant kind of stuff. Okay? Here we're going to prove some identities. So this is going to look like using one of the pieces that we just learned and then moving into more looking like 5-1 and 5-2. So here we go. Prove the identities. Cosine of pi over 2 minus x is equal to sine of x. Well, we're going to pick the complicated side. So I'm going to say, okay, I've got cosine of pi over 2 minus x equals sine x. I'm going to rewrite the side. So I've got a difference here. I'm not going to use, where is it? I'm not going to use my cofunction formulas right now, okay? We're going to consider that kind of cheating. So we're not going to use our cofunction formulas. We're actually going to use sum and difference formula to practice using those. So what we're going to do is we're going to take this, and without using one of the cofunction identities, we're going to split this apart. And so it's a cosine, so we're going to go this way. Cosine of pi over 2 times the cosine of x. And it's cosine, so this is opposite, plus sine of pi over 2 times the sine of x. And let's look at what happens. Knowing what we know about the unit circle, and I told you that this thing wasn't going to go away. If I think about the unit circle, I've got this here, pi over 2 is up here, so its coordinates would be x is 0, y is 1. So this is the sine. So the sine, the cosine is 0, so this is 0 times cosine x, plus the sine of pi over 2 is 1 times sine of x. So this cancels out, so I literally have sine of x is equal to sine of x. And so we just proved that identity there. So instead of using one of these cofunction identities and just saying, oh, well, I know that that's true because it's on the sheet, I can split it up using an angle sum or difference formula as well. Same thing over here. So if I've got this sine of pi over 2 minus x is equal to cosine x, that's going to be one of these cofunction identities as well. So sine of pi over 2 minus theta is equal. You can split that up as well. You could split it up and use your cofunction, no, not the cofunction identity, the sum and difference identities to do that. Okay? Let's talk about another couple of things. The other one that we can use is the tangent formula. We haven't talked about that one yet. Tangent of u plus or minus v is equal to, and we're going to put the tangent of u plus or minus the tangent of v over 1 minus or plus tangent u tangent v, okay? That's v. Okay, and so it's going to work in much the same way as these other ones do. So I've got an angle addition formula or subtraction. The sign on top matches, the sign on bottom is opposite, and we got to make sure we line up our angles where they need to go, u and v wise. Okay, so let me see. Let me pick through these examples here. Example. Express as the sine or cosine of a single function. Angle, sorry, of a single angle. Okay, so here's example A. So the directions are, take this long thing, express it as a single angle. So, for example, they might give us the sine of 22 degrees times the cosine of 13 degrees plus the cosine of 22 degrees times the sine of 13 degrees. And so they want us to take this and write it as sine or cosine of a single angle here. Well, take a look here. This looks like, and if you check out your sheet here, it looks like the sine formula. Okay, so I know that this is going to be the sine because cosine, when I'm using an angle sum or addition, or sum or difference, has cosine, cosine, sine, sine. So because they're mixed, I know that it's sine. The sine is a plus, and for sine, remember, for the sine matched, right? So if I'm adding in this, I'm going to be adding here. And then I'm going to do 22 plus 13. So this is the sine of 35 degrees, okay, which is not on the unit circle, neither are these two other things, but that's a way that we can rewrite it as a single angle. Check this one out. Cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. All right, so check this out. Obviously, we've got cosine and cosine, and sine, so there's going to be a cosine. Cosine was opposite, so if this is plus, we're going to have minus. And this is going to be pi over 3 minus pi over 4. A couple ways to do this. You can convert to degrees or just use a common denominator. So this is really equal to the cosine of 4 pi over 12 minus 3 pi over 12. And so that would be the cosine of pi over 12, which again is not on the unit circle, but that's a way that we can get there from here. Okay? I'm not sure, guys. I think that's pretty much it. It's very straightforward. It's a lesson that, it takes a couple of little nuances, knowing that, sine, the sine matches, cosine, the sine is opposite, and kind of seeing the flow, but it's on your sheet, and it's using another one of these formulas. So, you know what, guys? Thanks for watching, and we'll see you next time.